ready for takeoff.
Hello, everybody, and welcome to my talk today, Analyzing an Analyzer, a dive into how RuboCop works. RuboCop is quite complex, and I don't think we can do an exhaustive study on it, so this will be more of a regular dive, and not a deep dive. My name is Kyle D'Oliveira. I'm based out of Vancouver, Canada. I've been working with Ruby and Rails for well over a decade now. I'm in love with the language. I love the community. I love spaces like this where we can interact with each other and get a sense of what the Ruby community feels like. I'm really drawn to tools that can benefit the entire community, and RuboCop is no exception to that. And my hope is that after listening to this talk, you'll understand some of the basics about how RuboCop can analyze and correct code, and maybe some of you will feel inspired to either contribute custom rules for yourself, your organization, or even to the open source repository, or even start playing around with new tools that utilize similar ideas or concepts. I have been working at AHA for the past 2 years, and it is one of the best workplaces that I've been a part of. We are a human-centric company that's helping other companies build the products that matter for them with our suite of products. And we have an amazing team that's distributed by design all over the world. We have one of the best company cultures that I've seen, and it's powered by the responsive method, which gives us a framework of shared values that we all agree upon and embody, and it really helps empower us so that we can move quickly and stay aligned. So if you'd like to be part of that culture, of course, AHA is hiring. Linters are a static code analysis tool that can be used to flag programming errors, suspicious constructs, stylistic errors, but it can be used to do more too. It can be used to alert around security. It can be used as a tool for training other engineers. And RuboCop is one of the most popular linters for Ruby. And I'm just a little bit curious, just from a quick show of hands, has anyone here not worked with RuboCop before? So I don't think I see a single hand, and that's about what I expected. Rails is one of those gems that is very closely tied to Ruby. So much so that there's often the assumption if you say you're working with Ruby, they just assume you're working with Rails. And to put things in a little bit of perspective, Rails has been downloaded about 387 million times off from Ruby gems and is about the 40th most popular gem. RuboCop has been downloaded about 270 million times and is about the 76th. While not as popular as Rails, RuboCop is up there that when you talk about Ruby, you're also thinking about RuboCop. And the original creator of RuboCop gave another talk about this in 2018 at a Ruby Kaigi. So after this talk, if you're really curious about learning more about RuboCop, this is a great resource. You can learn more about RuboCop from him. And I wanted to begin today's talk with a little personal story. I first got into using RuboCop several years ago. And it was at a point where we were trying to figure out how to have an agreed upon style for all the code that we were writing. But we would end up with pull requests that were just full of these nitpick comments that wouldn't really be talking about the content of the pull request, but instead talking about how the code looked. And sometimes these would be fine, but in other times we would get into big and often pointless arguments over what seemed like the most trivial kind of things. We would get into big debates of whether or not we should use single quotes or double quotes. What is the maximum line width? Whether or not we need to have an extra line at the end of a guard clause. And we thought that if RuboCop could handle our linting and styling for us, we could focus all of the comments of pull requests on the actual content of the pull request. And this helped a lot, except for that it was also incredibly frustrating to work with. We would write code, we pushed up to CI, and CI would reject it because RuboCop would flag violations, and we would go back and we'd fix them and do it again. I had a project in which I needed to namespace a huge number of constant references, so all of the lines became longer. and the maximum line length rule became the bane of my existence. I'd have to hunt down from CI every line that was over the length, figure out how do I break this up into pieces, and I hated it. And many engineers had the similar experience, and the message of not liking how RuboCop was rolled out started getting mixed up into the message of, we hate RuboCop. But then we started really leaning into RuboCop and learning about how we could use autocorrect, and a lot of the frustration of RuboCop started to disappear. We could have RuboCop fix our code for us. If it detected something that was a violation, we could have it handle it automatically, and most of the time, those changes were perfect. And so we kept leaning into this as well. We started writing our own custom cops to help us migrate bad patterns to good ones. We wrote some to keep deprecations under control as we were upgrading Rails. All the while, we were using error messages from RuboCop as a way to explain concepts, link to internal documentation, and give reasons why certain decisions were being made. I gave a talk at RailsConf at 2020 illustrating how RuboCop can be used to communicate information about bad patterns in code. And that is another resource that you can look up later if you are curious about learning more. And this year, RuboCop turns 10. And in the open source world, this is a pretty big deal. Development of RuboCop has been pretty consistent throughout the years. And with where we're at, I don't see RuboCop going away anytime soon. But it's large enough that understanding how RuboCop works can be really tricky. There are thousands of commits, thousands of closed issues, hundreds of contributors and releases. This is not going to be a code review of RuboCop. I don't think I could cover it and do it justice, and it would probably be very overwhelming. With the history of RuboCop, it's a bit of a marathon, and we've got 30 minutes here. It's a bit of a sprint. So instead, this talk is going to be a dive into how does the basics work. I will outline the basics and help illustrate how some of the processes function inside of RuboCop, with the aim to stay as close to how RuboCop works as possible, but I might make some simplifications in this talk just for the purposes of the talk. So let's dig into this. How does RuboCop work? And I thought of a good way to dive into the details of how RuboCop works is to start by looking at the command line interface. How does this work for a single file and a single cop? So what happens when you run the RuboCop command? Well, at first it will run the executable file, which loads up the Ruby library and processes, and then loads some configuration. And these two steps are the easy part. I'll touch on them a little bit for completeness, but there shouldn't be too much surprises here. But then we'll get into the meat of RuboCop. At some point, RuboCop will need to process a file. And that is to take a file that exists and do something to it so that it can make decisions about that file and the code inside of it. Once it's processed this code, it will need to run it through a series of cops that will make decisions on whether or not there are any offenses. And if there are, it can write those or rewrite that source code and change the file. And then it will loop back once it's finished changing the file and potentially start again. And this loop is important as multiple different cops can adjust the same line of code. And so you may need to process the code a couple times. Also be wary of getting into infinite loops. So we'll break down this process into these steps. And at the start of it all is the command line interface. Now this is pretty straightforward, and I'm going to go pretty quick here, as this isn't a talk about command line interfaces, this is a talk about RuboCop. Effectively, there's just a executable file called RuboCop. It's configured to use Ruby. It loads the appropriate libraries into the load path, requires RuboCop, and then does some kind of processing. And this is where we go from the command line into the world of Ruby, and this is our RuboCop's entry point to doing whatever it wants to do. And the part that it wants to do next is start loading some configuration, determining which cops are active, what options do we need to provide to them. In general, this is all done through YAML files. I won't go through the options here. They have a pretty well documented online about what options are available or not. Effectively, there is a big YAML file where you can give it some options that are provided to all cops, for instance, and you could say which Ruby version you're looking for. Here are some file patterns to include. Here are some patterns to exclude. You can also provide specific configuration for specific cops. You can nest the configuration based off the cop's name, and then that configuration is then available inside of the cop itself. Now that's pretty quick, but that's, at the end of the day, it's just all loaded with YAML, and then it is a hash inside the Ruby process. There's not too much fancy going on there. But this is where we get to the more interesting part of the whole process, processing the code. And this is a bit of a meta topic because we need to talk about code that understands code. And to illustrate how this really works, I'm going to be leaning into this specific example. RuboCop has a style cop called ArrayJoin that its purpose is to check whether or not there is a star method that is being used to join values of an array. So imagine we had some code and we want to determine if any of these bad patterns exist in the code. And if it does, we want to flag the code as violating this rule. So imagine we've got our array, or here we've got an array of strings which contain foo, bar, baz that are being joined with the star method and joined with a comma. If we wanted to ask, does this code violate the rule? As a human, we can say, yes, obviously. But how do we write code that determines this? One option is that we could reach for our fancy tool of regular expressions. And we can start with something that already looks pretty complicated. It looks for an open brace, a bunch of non-closing braces, closing brace, space, star, space. It's pretty complicated. This would match this code, though. So in this specific example, we could use a regular expression. But in the world of Ruby, things can change. What happens if we use single quotes? Well, we could update our regular expression to do something with this. We'll figure out which quote, you have a back reference for it. Again, we can write things in different ways. If there's no spaces, what do? We can continue adjusting the regular expression. But at some point, we could write this in a completely different way. We use a %W notation to write a series of white space delimited strings. At this point, I don't really know how we would do a regular expression to kind of match this kind of code. And it can get more complex. You don't even need parentheses. You can use almost any character to delimit this array. So this just gets more confusing. And we can continue down this path. What if this code was in a comment? What if this code was in a nested array? What if there's dynamic strings in here? And using a tool like regular expressions just wouldn't be sufficient to make decisions about code like this. I have to include the obligatory XKCD comic whenever talking about regular expressions because often you end up with more problems. But there needs to be a different way. And what we need to be able to do is we need to take Ruby code and break it into the abstract syntax tree that what it represents. And this abstract syntax tree, or the AST, is a representation of the code. So for example, we have a begin rescue block like we do in the corner. This is what the corresponding abstract syntax tree would look like. Now, it is a lot, so I will break this down. And Ruby has a gem that can handle converting code into an AST called parser. It comes with Ruby. You just need to require it. And you can get a representation of what any Ruby code looks like as an AST. So let's come back to our array example. What does the abstract syntax tree here look like? Well, first, this entire thing is a method call. And this is represented by the send node. The send node has many children. The first child of it is, what is this method being called on? So in this case, it's being called on an array. And that array contains 3 elements, a string foo, a string bar, and a string baz. The second child of the send method is the name of the method that is being called. So in this case, the method name is star. And the rest of the children of the send node are the arguments that are provided to the method. So in this case, there's only one argument, and that's just a string that is a comma. Now, if we come back to what the code looked like, and we wanted to check what the abstract syntax tree looked like with parser, we can run this code through parser, and when we format it, it would look something like this. And what's great about this abstract tree or abstract syntax tree representation is if we start writing this code in a different way, we use single quotes instead of double quotes, the abstract syntax tree doesn't change. If we write it without spaces, the abstract syntax tree doesn't change. And this is true for the %W notation as well. So this is what RuboCop uses under the hood to be able to make decisions about code. They have a utility gem available called RuboCop AST that extends the functionality of the parser gem to make things a little bit more simple or easier to read. So RuboCop has this process source class that you could use if you wanted to, where you could provide it some code in a string form. So this could be read directly from a file and the version of Ruby you are interested in, and you can look at the abstract syntax tree and start to ask questions about it. So if we looked at this code and we wanted to know if it violated that array join rule, we could start asking some questions. We could ask, is this a send type? And we could say, yep, it is. We could look at the receiver of this method and ask, is it an array type? It is. We could check to see if the method name is star. And we could also look at the arguments. Is there one argument? Is that argument a string? So this gives us a way to start asking meaningful questions of code in a very repeatable manner. Okay. So now that we have a little bit of understanding about how RuboCop is processing the code, how does it actually start applying the specific cops? To understand that, we need to make our example just a little bit more complex. What if our array joining code is wrapped in a method? This seems to throw a bit of a wrench into things. We can no longer ask if this is a send type anymore. It's not. This is a method definition. We can't ask if the receiver is an array type because there is no receiver for this method definition. The method name here is not star. We do have one argument though, so that we do have that going for us. What we need to do is we need to break this code down into its abstract tree representation, abstract syntax tree representation. And when we do, it looks something like this. You can see the original send node that we wanted to focus on is there, but it's wrapped in another node, this def node. So in order to navigate and find these various nodes, we need to walk through the abstract syntax tree. So what we'll go through next is a very simplified version of how do we walk in abstract syntax tree. To do so, we could start with a method like walk. And the goal of this will, can we visit every single node inside of this abstract syntax tree? To do so, we'll start with passing it the entire abstract syntax tree, and we'll need some sort of convention on determining what do we call the methods for our various nodes. So for this, we'll create a method for each node type that's prefixed by on. So here we'll need a method called onDef because def is the top level node of this abstract syntax tree. From here, what does onDef do? Well, in order to understand this method, we need to know what does the def node in the abstract syntax tree look like. It has many children. Its first child is the name of the method that's being defined. This is a symbol, so we don't need to do anything further here. The second child of the def node is the arguments that are passed in. So to deal with this convention, we'll create an onArgs method. We'll hand it the arguments that will continue to recursively visit these nodes. The last child is the body of the method. It could be a few different things, but to keep it simple, we'll focus on what it is here. So we'll need to write an onSend method. So now we can start looking at those methods. What does the onArgs do? This has many children, and each child is an arg. So we could walk through each of the children of this piece of the AST and call onArg on each of them. And the onArg itself doesn't need to do anything further. It doesn't have anything further nested, so we don't need to do anything to navigate this entire tree. Moving back over to the onSend method, the send node itself we've gone over before, and we know that the first child is the receiver, so we can call it the onArray here. The second is the name of the method that's being called, which in this case is star. It's a symbol, we don't need to do anything further. And the rest of the children are the arguments to the method. So in this case, there's only one argument, which is the string, so we'll call the onStr method. Almost done here. The onArray method looks very similar to what the onArgs look like. We go over all of the children, and we need to call a method based off what type is inside of the array. So in this case, we just call onStr on each one of these elements of the array. And lastly, the onStr method doesn't have any further children, so we don't need to do anything. And so utilizing all of these methods, we can visit all elements of this abstract syntax tree, and based off where we are in the tree, we can start to tie in behavior of what we want to do. And this is all fairly complicated still, but RuboCop AST, that gem that I talked about earlier, has abstracted this away into a module called RuboCop AST traversal. And using this, it can traverse over any arbitrary abstract syntax tree. It'll visit each node of the tree in a depth-first search. And if any of the cops that are active define methods that are interested in each piece of that abstract syntax tree, it will hand that node over to the cop to handle its own logic. So what this could look like is we could have a class that includes this module, and this would allow it to traverse over any arbitrary abstract syntax tree. And the object could hold a reference to whatever cops are available and enabled. And then for each type of node, it can walk through the cops that are available, determine if they respond to that method, and if so, give them that piece of the abstract syntax tree. I've only listed a single method here, the onSend, but effectively this is what RuboCop does. It does this for every possible type of node. And if we were to look at what the cop for that array join cop looks like, the source code for this, while there's a lot going on here, the main thing here is that the cop just defines an onSend method. And this is past every send node. So this cop, when run through RuboCop, will see every method call that is in your source code. And this will allow the cop to ask specific questions to that method call. Is the receiver an array? Is the method name star? And if it matches everything that it needs to match, it can record an appropriate offense. And this is how each cop ties into the source code. If we were to look at another cop example just for a quick moment, we can see something similar. For instance, if we look at this cop, which is the min-max cop, it is looking for when the min and the max are returned as two elements of the same array. This would need to do some sort of logic on each array that it encounters. The source code for this just defines an onArray method, which can then tie into every single array definition, and it can start asking questions about this array. Does this match the min and the max? This allows each cop to focus on only the pieces of the abstract syntax tree that they're interested in and make very focused decisions. And there are many, many different types of nodes possible in the abstract syntax trees. You could have nodes for local variable assignments. You can have nodes for class definitions or for yield blocks. Some of these nodes, I'm not entirely sure how you would even write Ruby code to represent them. But if you can represent them as an abstract syntax tree, RuboCop can tie into that piece and start making decisions about it. So finally, we get to a point where we can start asking RuboCop, how does it change the abstract syntax tree and autocorrect it? If we were to take the method that we looked at earlier and we were to fix it, we would want to do something like this, where we remove the star, replace it with join, and wrap the arguments. Lucky for us, the parser gem that we talked about earlier has a class called the tree rewriter. And as they say, it performs all of the heavy lifting for the source rewriting process. So you can have multiple rewrites, and it will perform them all in the correct order. And the general structure would look something like this, where you can get the abstract syntax tree for any arbitrary source code and pass it along to the tree rewriter class. But from here, what can we do? One of the things you can do is called the replace method, which, as the document says, will replace the source code with a specific range with new content. We can do other things with the tree rewriter, such as adding things before or after or removing content, but we'll focus on this for right now. And two immediate questions should pop up, which is, what is the range, and how do we determine the content? Well, looking at the range is this special class that comes from the parser gem itself, and it outlines a range of characters that represent various Ruby expressions. And there's a method available on all of the code that is parsed with parser called location. And this gives a lot of really interesting aspects of that piece of the abstract syntax tree, but one piece of that is the expression. And that provides the range for that entire piece of the abstract syntax tree. So if we were to focus on that send node, which we determined was the third child of that overall AST, we can get to where this source code is located by looking at the location.expression. And this is how we can get the range of what code needs to change. Now, when we start looking into content of how do we determine the content it should be replaced with, well, we knew that the receiver was an array type, but we can ask more questions about this receiver. For instance, we can ask it explicitly, what's the source? And this will give us exactly as it was written, the source code of this array. And we can save this as a string to use later. Similarly, we can look at the arguments and look at the source of the arguments, and this lets us get explicitly from the code exactly that was passed in. Putting this all together, we can get something like this, where we set up our code, we set up our tree rewriter, we focus on that send node specifically, and we grab the location of that send node using that location.expression. We can get the source array, we can get the source arguments, and we can call this replace method to wrap this array or with this join that wraps the argument. And from here, we can have the tree rewriter process it, and we end up with this rewritten method exactly the way we wanted it. And effectively, this is what RuboCop does. They have their own corrector, which is an object that wraps the tree rewriter, so you don't need to know certain things like the location expression. You can pass in directly the piece of the abstract syntax tree. But all of the other methods, such as replace, are available. And this allows each cop to handle its own changes whenever it detects something that violates a certain pattern. And when it's done, RuboCop will write these autocorrected changes back to the file, and if necessary, reprocess the new file and start again. Okay, so even after now 28 minutes, this can be a lot. This is a crash course through RuboCop. We've gone through some of the different pieces, simplistic version of RuboCop. We've gone through pieces of the command line interface and configuration. We've walked through how RuboCop can take that file and convert it to an abstract syntax tree so it can interact with it. We talked about how it could then traverse that abstract syntax tree and rewrite it and then write it back to the file. I'm hoping that this has helped you understand a little bit about how RuboCop functions. And I hope this has got you thinking about how you can start utilizing this knowledge. As I mentioned earlier, there's some other great resources online if you want to learn more. But if you are interested in building a tool that needs to analyze source codes, there's probably little bits of pulling from the abstract syntax tree or walking through an abstract syntax tree that could all be really useful. I hope you found all of this really interesting. Thank you for your time. I don't know if we have time for questions, so I'm just going to end it there. If you have questions for me personally, come up after the talk and I'll be happy to answer.